Hello everyone. This video is from a text on introductory statistics in a section titled Definitions of Statistics, Probability, and Key Terms. So in this video, I'm going to be taking you through section 1.1 of the openstacks.org Introductory Statistics text. This is a free online textbook. And section 1.1 is again titled Definitions of Statistics, Probability, and Key Terms. And then I will also be taking you through some exercises from this text at the end of the chapter on section 1.1. Alright, so we have here the science of statistics deals with the collection, analysis, interpretation, and presentation of data. And then as you read through, there are exercises that you can read and whatnot. I'm just going to go over some definitions in this first chapter. So in this course, in this text, right, you will learn how to organize and summarize data. Organizing and summarizing data is called descriptive statistics. And then they go into some more things you can read here. And then you will use formal methods for drawing conclusions from good data, right, after studying probability and probability distributions, of course. And these formal methods of drawing conclusions from data are called inferential statistics. Both of these will be touched on much more later in the text in later videos. Alright, and then they get into probability, and you're not really given too many exercises on probability, but probability is a mathematical tool used to study randomness. Right? It deals with the chance or the likelihood of an event occurring. And they go over some examples here. I'll leave for you to read, of course. Some key terms that will actually be asked about in the exercises. In statistics, we generally want to study a population. Right? A population is a collection of persons, things, or objects under study. Right? To study the population, we select a sample, right? A smaller sub-collection of the population. The idea of sampling is to select a portion, right, or a subset of the larger population and study that portion to gain information about the population. Right? Data are the result of sampling from a population. Right, and they have an example here in this paragraph, which again I'll leave most of this. I'm assuming you're reading the text. Right, then from the sample data, we can calculate a statistic. A statistic is a number that represents a property of the sample. Right, so statistic goes with sample. I think an easy way to remember that is that they both start with the letter S, right? Statistic, sample. And a statistic is an estimate of a population parameter. A parameter is a numerical characteristic of the whole population that can be estimated by a statistic. Right, so a parameter is a number describing the entire population. Parameter, population, both begin with P, P. And when we take a sample and calculate a statistic from that sample, that statistic is an initial estimate of the parameter. And then again you read on. Another bold word here. The sample must contain the characteristics of the population in order to be a representative sample. Right? So we would like, when we gather a sample, we would like that sample to have as many similar characteristics to the population as possible, right? Be as close to the population as possible. A variable, usually noted by capital letters, is a characteristic or measurement that can be determined for each member of a population. So for example, right, going through all people and just recording their heights or their weights or political parties or whatever you see in their example in this paragraph here. Variables may be numerical or categorical. Right? Numerical variables take on values with equal units, such as weight in pounds and time in hours. Categorical variables place the person or thing into a category, right? Non-numerical, a label, a category. Then here, data. Data are the, let me actually, no, I should have done this in the beginning, zoom this in a bit. My apologies. Data are the actual values of the variable, right? The values being recorded. They may be numbers or they may be words. And then datum or datum is a single piece of data, a single value. And of course, two words that come up often in statistics are mean and proportion. Mean is otherwise known as the arithmetic average. You take all your data values, add them up, divide by how many there are. A proportion is, what fraction of the data, what percentage of the data satisfies a certain characteristic. But we'll talk plenty more about mean and proportion in later videos. And then the author makes a note saying, the words mean and average are often used interchangeably. The substitution of one word for the other is common practice. The technical term is arithmetic mean, as I said out loud earlier. And average is technically a center location, right? So, people that are non-statisticians, in most times in everyday life, you hear the word average and you think about this arithmetic mean, right? Adding things up and dividing by how many there are. Just understand that when you see the word average in a statistics book, or when a statistician is talking about average, the word average could mean multiple things. So you have to really specify, do we mean the arithmetic mean, or, and we'll see later, the median, the mode, mid-range, harmonic mean, geometric mean. There's all sorts of different things that could be represented by the word average. So just be careful whenever you hear the word average. And then you got examples you can read, try it problems. I would recommend practicing these and trying to do them first before you look at the solutions. And there's plenty of examples and exercises. All right. So now I'm going to skip over to the Chapter 1 homework, which is later in the table of contents, later in the chapter at the end. And I'm just going to go over the homework problems for section 1.1 that I just kind of glanced through, skimmed through. So for the first exercises, looks like from 42 to 49, we're asked for, each of the following 8 exercises. Identify, A, the population, B, the sample, C, the parameter, D, the statistic, E, the variable, and F, the data, and give examples where appropriate. Alright, so I am going to just be doing for these videos the ones that I can show you the solutions for and we can check if we're correct. course, there are also, and that's these odd numbered problems. Any problem in the OpenStax books where you can actually click on the number, there's a link on the problem number. Those have solutions in the text. Perhaps later I'll make a video where I go over the even numbered problems, but they're all very similar. So I'm just going to be doing the odd numbered problems here. Okay, so for question 43, we are given the following scenario. Ski resorts are interested in the mean age that children take their first ski and snowboard lessons. They need this information to plan their ski classes optimally. So I'll do this, or hopefully we can see number 43 at the top here. Okay. And hopefully you can see my work page here. So I'm in section 1.1, number 43. And for part A, they're asking us for the population. All right, so the population, right, that's everyone that's under study, right, that you're trying to gather data on. So here, ski resorts are interested in the mean age that that children take their first ski and snowboard lessons. They need information to plan their ski classes optimally, right? So like the population is children. Now we could say children, all children, but more specifically, we're looking at children that take ski and snowboard lessons, right? So children that take ski and snowboard lessons. All children that take ski and snowboard lessons at these ski resorts. Right. So that I would consider that the population. Now, of course, when I look at the solution in a minute, they may have it worded a little differently, but again, just all children that take these ski and snowboard lessons, we're going to be looking at them. All right, then part B was what's the sample? What would be considered a sample here? So I'll throw the word all in front of the population, because the population's everyone, right? Everyone that's considered for the study. A sample is a sub-collection, a subset of the population. So it's just a collection of some children that take these lessons. And I'll underline the word some, right? Some of these children, not all of them. So a collection of some children that take these lessons. Ski and snowboard lessons. Okay. Part C, they asked us for the parameter. Right? What aspect, what characteristic of the population are we looking to calculate? So the parameter here, right, it says it right in the problem, right? They say ski resorts are interested in the mean age that all children that take their first lessons when the average age, the mean age of all the children that take their first ski and snowboard lessons. So that's the parameter. the mean age, right, of all these children that are described up here in the population. And I'll underline the word all again. Right. Again, population, parameter, p. Right. And then part D, what's the statistic? So as I read earlier, right, a statistic is a number describing a characteristic of a sample. And the statistic we calculate from the sample should estimate a parameter. So whatever statistic I mention here should be will be an estimate of the parameter. So if the parameter I'm looking to calculate is the mean age, that will also be the statistic. The mean age, though, not of all the children, but of my sample of children. Right, the mean age of the sample of children that were collected. But statistic has to go with sample. All right, in part E, what is the variable? Remember, the variable is just when I go from individual to individual, what is being recorded. So if we're looking to find, the mean age of, this a sample of children, I would go from child to child asking for their age or recording their age. So the variable here is simply, age. And typically we throw units on this, maybe age in years. How old is each child in years, I would say. It could be days, months, you could do that kind of stuff too, but the variable is age. What's being recorded from individual to individual in the sample. And then finally, what are the data? Right. The data are just what are being recorded. It's the actual numbers themselves. The data here would be the ages of the children in my sample. Right. The ages of the children in the sample. So again, the actual values. Now let's take a look. In the text, you can just click on the number 43 here with the link on it, and it'll take you to the solution in the solution part of the text. And you see the population, right? All children who take ski or snowboard lessons. B, right? The sample, a group of these children, right? A collection of some of those children. C was the parameter, right? The population mean age of the children who take their first snowboard lesson or ski lesson. D was the statistic, right? The statistic was the sample mean age of the children in your sample. I guess I forgot to label the variable with a capital letter. Right, that was mentioned in the text that usually variables are represented by some capital letter. So you're seeing here X is equal to the age of one child, right, who takes his or her first ski or snowboard lesson. But it's age, right? Again, what's being recorded from child to child? It's the age. Right, so you see the variable is the age. And then finally, right, the data themselves, right, are the values of X. The ages, 3 years old, 7 years old, right, the actual numbers that are being recorded are the data. Okay. And then if I'm done with the solution, I can click back on the number and it takes me right back to the exercises, which is very nice. And then we can move on. All right. So I'll read this one off and then pull up my paper again, and we'll do number 45. So section 1.1, number 45. So this time, right, insurance companies are interested in the mean health costs each year of their clients so that they can determine the costs of health insurance. All right, so I'm not going to write that out, but A, what's the population there? Remember, the population is just everyone considered for a study, everyone you're considering on recording data for. And it says they're interested in the mean health costs each year of their clients. So the population is all of the clients of that insurance company. All of them can be considered here. Now, part B, right? A sample would be just some collection of these clients, not all of them, but just a collection of some of the clients. Part C was what's the parameter? Parameter, remember, is a number that is describing a characteristic of the population of all the clients, and they wanted to, it says, the insurance companies are interested in the mean health costs, each year of their clients. So the population mean health cost. Right. So we're going to go through every single client, say what were your health costs this year? What were your health costs this year? What were your health costs this year? Right, one at a time. And then add those up, divide by how many there are, right, find the mean health cost. Now for the population, right, we're not doing the entire population, but if I were to, right, that would be called a parameter. What we do most often is find a statistic. Remember, a statistic is that basically that same number, but for the sample. What's the sample mean health cost? So I would go through every client in my sample and ask them, what was your health cost this year, your health cost this year, your health cost this year, and then find the mean of those values. Part E, the variable, which this time I'll remember to call it a capital letter, X or Y or H for health costs, but say I use capital X equals, and then what's being recorded from person to person, right, in the sample, individual to individual, and that's those health costs, right? Yearly health costs are being recorded. So health costs for the individuals in the sample, but I'm not going to write all that out. And then the actual data are the values of X, right? The health cost numbers for each individual. The actual data that's being recorded. So, this person paid $20,000, this person paid $1,000, this person paid $3,000, whatever. Those dollar amounts would be the data. Right. I hope that's clear. Again, let's take a look at the solution just to double check ourselves. So the population, all the clients, a sample, right? A group of these clients. Population parameter, right? Parameter is the mean health costs of these clients, all the clients. Whereas the statistic is the mean health costs of just the sample. X is the health costs, right? The variable is the health costs of each client, right? And then what is the data? Values of X, right? $34, $9, $82, and so on. The actual values are the data or data. Great. All right, so just a couple more of these. So again, very similar, all of them. Hopefully the definitions are clear. So section 1.1, number 47. Again, I'll just read it here and go to a piece of paper. A marriage counselor is interested in the proportion of clients she counsels who stayed married, right? So what percentage, what proportion of clients that she counsels actually stay married after counseling? So here the population is everyone she's considering. It's a marriage counselor is interested in the proportion of her clients, the clients she counsels. So the population is all her clients, right? All her clients, right? Every single one of them would be considered the population here. Whereas a sample would just be some of her clients, right? Just a sub-collection, a subset of her clients that she counsels. Then the population parameter, right? The parameter in this problem is the population proportion, right? The population proportion of her clients that stayed married. Right, now to calculate a proportion, it's a fraction, it's a ratio, it's a percentage. You would take, how many clients stayed married and divide that by the total number of clients. That would be the proportion of clients who stayed married, the fraction, the percentage. And we would do it for the entire population, right, if we were talking about it being a parameter. But as I said before, usually we don't look at the entire population. What we do is we estimate the parameter with a statistic, right, a value from the sample. So it's the sample, right? The statistic here would be the sample proportion of her clients who stayed married. I'll just say proportion who stayed married. Right. E, what's the variable? Now here, you would just be going client to client and simply asking or looking at if they were married still or not. So here it's the marriage status. I'll call it, capital X. Maybe I'll call that the marriage status of each client. Right, married or not are the only things that be recorded, but I would call that maybe marriage status. So you go client, what, married or not? Is this client married or not? Is this client married or not? Right, you just keep going down the line. So the variable is marriage status, and then the actual data are the values of X, right, for each individual. The values of the variable, which again is, you got married, not married, married, not married, not married, etc. You would keep doing that. All these values here would be considered the data, right? What you're actually recording from person to person. So let's take a look again. So all the clients of the counselor, right? The population, just a group of those clients, a sample. The proportion of all her clients who stayed married, right? The population proportion would be the parameter. The proportion of the sample who stayed married, the statistic, right? That estimates the parameter. X equals, the number of couples who stayed married. And I guess you could call it that too, because she's just recording how many stayed married, how many didn't. And then instead of married, no, married or not, it is, the data here is just yeses and nos, the way they're writing it. But it's still, how many, married or not, and you can count up the number of couples who stayed married for X. And then the actual data, the actual values are married, not married, right? Those are the values being recorded by this counselor. So worded a little differently, but same meaning as what I had written. All right, then the final exercise of this part, a marketing company. So again, the final odd numbered exercise. A marketing company is interested in the proportion of people who will buy a particular product. So 1, number 49. So, again, part A, what's the population? Well, it says a marketing company is interested in the proportion of people who will buy a particular product. So the population is just all people? Really? I mean, to be serious there, it's all people. Now, it could be all people in a particular country or in a particular county or all people everywhere around the world. It didn't really specify. More likely, it would be all people, in the region that this marketing company operates. But we'll just say all people, who can purchase stuff. All people. And then a sample, right, would just be some of these people. A group of some people. The population, parameter that's of interest, they're going to try to estimate, is the proportion of people who will buy a particular product. So the proportion of all people, right, of the population, it's a parameter, who will buy a particular product. then the statistic is just going to be an estimate of the parameter, and it's the sample proportion. Right, you go through the sample of people and say, would you buy this product or not? You do that to each person, and you count up how many would, and divide it by the total size of the sample, right, for that fraction, that proportion. So let's say sample proportion, right, who will buy the product, but the key word there is sample, right, sample for a statistic. The variable, now based on the way the solution to the last problem looked, maybe the variable is counting up the number of people in the sample who would buy the product. But we could also record, what's being recorded here. I could also go through and record this person. Are you buying the product or not? Are you buying the product or not? Are you buying the product or not? So, the variable here is, what's being recorded is answer to question, would you buy this product? Sorry, buy this product. Because that's what's being recorded from person to person. Now, of course, you could also call this, number of people who would buy this product, which I think they'll do in their solutions. But either way, you're trying to determine how many people would buy a particular product, and then the data are the actual answers to that question, right? Which would be yes or no, right? So you got this person says yes, this person says no, this person says no, this person says yes, and all those recordings of yes and no are your data. Again, just double checking here, looking at the solution that they're recording. See all the people, as I mentioned, right? Maybe in a certain geographic area, like just a specific country like the United States, or a specific region of the country. We'll just say all people for the population. Just a group of those people for the sample. The parameter, right? A proportion of all the people that you're considering who would buy the product. The sample statistic, the proportion of just the sample who will buy the product. The variable x, they're saying, is the number of people who will buy it, right? Again, or as I wrote, say x is the answer to the question, would you buy the product? It's what you're recording. And then buy, not buy, yes, no, for the data. What are you seeing? What are the actual values being recorded? Okay, wonderful. All right, so hopefully the concept of population, sample, parameter, statistic, and then the variable and the data, what a variable is and what data are. Hopefully all that stuff is clear after those several exercises. All right. So in the next exercises, it says use the following information to answer the next 3 exercises. So a Lake Tahoe Community College instructor is interested in the mean number of days Lake Tahoe Community College math students are absent from class during a quarter. All right. Now, number 50 is simply what is the population she's interested in? That's all the math students, right? There's no answer to this in the back, but it's very clear. This professor is interested in just math students only at this college, right? So all Lake Tahoe Community College math students would be the population. For 51, consider the following variable, right? See the capital letter here. X equals number of days a Lake Tahoe Community College math student is absent. In this case, x is an example of a variable, right? I already said that, right? It, represented by a capital letter, and it's something that can be recorded from person to person, right? Individual to individual in a sample. I take a sample of math students at this college, and then this first math student, how many days were you absent? Second math student, I asked the same thing. Third, you record this for each individual, and it varies, right? It varies from person to person. That's variable change. So a variable, and again, you can see very easily that when I click on the solution here, the answer is a. See, variable. And 52, the instructor's sample process produces a mean number of days absent of 3.5 days. This value is an example of a statistic, right? Because it says sample, right? The instructor's sample produced a mean number of, 3.5 days absent. So in the sample of math students, they were on average absent 3.5 days per person. And that will be an estimate of the parameter, right? This estimates the population mean days absent, but this is a statistic. All right, so again, there's no answer in the back here, but I just, these are multiple choice. I can go through these quickly. The answer here would be C. All right, 3.5 days there is a statistic, a number representing a characteristic of a sample. All right. That's it. All right, so I'm hoping that, again, you're reading through the text, read through section 1.1 carefully, take notes, practice the examples and the try it problems and the projects, and then going through the exercises. You saw the odd numbered ones in the video. Perhaps you'd like to practice the even numbered ones as well, and hopefully that all these definitions and concepts are clear, or clearer anyway, at the end of this. And thank you very much for watching.